Hello students, today we are going to discuss shortest job first in this video. We already done with the first come first serve. Now let us see what you mean by the shortest job first algorithm. Yes, as the name says, the shortest job is going to be taken first for the execution. The shortest job is going to assign the CPU first. Yes, the shortest job first is an algorithm in which the process having the smallest execution time, it's also called as burst time. Yes, smallest execution time is chosen for the next execution. Yes, whenever the time is to pick for the job to allocate the processor, so operating system will choose the criteria that at that time which all the processes are present in the ready queue, the smallest job is going to be picked up and assigns the processor to that the process or job, and it start executing. Yes, so this is a criteria here will be followed. This scheduling method can be preemptive or non-preemptive. So here SJF can be implemented using non-preemptive method also, preemptive method also. I hope everybody remembers the primitive and non-primitive. Non-primitive, once the process is assigned with the resources, it should complete its execution or voluntarily hand over the resources like CPU if it's going to the any other task. In preemptive, yes, the resources can be taken away by the operating system in certain conditions, like time is allotted for the particular process. If it expires, the CPU is taken away. Yes, that's called as preemptive. So SJF can be implemented using the preemptive method also and non-primitive method also. It significantly reduces the average waiting of the processes waiting for execution. Yes, it's compared to the first come first serve, it significantly reduces the average waiting time. Yes, so because some of the shortest job in the FCFS, we gone through this, right? So whenever a short job is waiting, if the long job is taken the processor, it should wait until it completes its execution. Here we are trying to take a shortest job so that it is going to execute, and number of process execution per time period is going to definitely it's going to increase. Yes, it can improve process throughput by making sure that shorter job are executed first, hence possibly have a short turnaround time. Yes, throughput, what just I told, it will increase the number of processes executed per time period. That's nothing but your throughput, right? So whenever the smallest job are picked and executed, obviously within a short term, many processes are going to be executed. So definitely throughput is going to be increased, and turnaround time, which includes the waiting time plus execution time. So waiting time of the short process are going to be very much reduced, and henceforth the throughput is going to be increased. Advantages: maximum throughput. Yes, the number of processes executed will be increased while when we use the this SJF method. Minimum average waiting time and turnaround time, which we always look for a algorithm. Yes, waiting time should be less for all the processes. Turnaround time, which includes the waiting time plus the execution time, that is also automatically reduced when it reduces the waiting time. So what are the disadvantages? may suffer with the problem of starvation. Once again, I am telling the starvation may occur in SJF also. Why? Because try to understand, if many short processes are go on coming in ready queue, and some of the long processes are there in a ready queue, they will wait for a long time, as at a particular time the criteria is to pick the shortest job. So if the shorter job goes on coming in a ready queue, obviously those are going to be picked up. So in some certain condition, the long job may wait for longer time to get the processor for execution. Yes, here also we can face the disadvantage of starvation. Coming to the next point, it is not implementable because the exact burst time for a process can't be known in advance. In advance means roughly I can tell it much. The process can take this much of time, not exactly the burst time or execution time. Getting is very difficult. It's not impossible, but very difficult. It should be in advanced technology we need to use. So these are the disadvantages of shortest job first. So let us move on to the examples. Non-primitive SJF. So we are going to here solve a problem using the non-primitive method, which means that if a processor is assigned for any process, that process voluntarily it is going to release the processor or the CPU. Means after complete its execution, in between OS cannot taken away the CPU, right? It's just opposite for the primitive. Now let us start with a non-primitive, taking some example. I taken the same example which I taken in a FCFS. You can see the first column with the processors. Yes, P1, P2, P3, P4, P5 with the burst respective burst time 5, 24, 16, 10 and 3. The same example here I took for SJF also. Fine. Now this is the problem statement. Consider the above set of processes that arrive at time 0. The length of CPU burst time given in millisecond. Now calculate the average waiting time and turnaround time using SJF scheduling. So when it's a problem statement given like this, we need to solve. You can notice here the arrival time is 0, means at the 0th millisecond all the processes are present in ready queue. Yes, so let us solve this. Before calculating the average waiting time and turnaround time, we always put a Gantt chart. Yes, similarly as in a FZF, first come first serve. Here also we will put the Gantt chart, but here the Gantt chart is something different. It's not start with the P1 because SJF tells that choose the shortest job first. Since arrival time of all the processes are 0, means I should consider in the ready queue now all the processes are there, P1, P2, P3, P4, P5. So it's a straightforward. I need to choose which is the smallest among all these. So obviously it's a P5, right? So P5 get the execution, get the CPU and start executing, and its burst time is 3. From 0 to 3 I represented here. Now I am done with the which process. Now here P3 is done. Now which all processes are left out? This is the P1, P2, P3 and P4. Among these four, which is the shortest job now? Is P1 with the burst time 5. Yes, so P1 will start at the 3 millisecond. Since the burst time is 5, 5 plus 3 is 8. Yes, now I am done with which process now? I am done with P1 also. Now I am left out with which all processes? P2, P3 and P4. Now among these, which is the less burst time, 24, 16, 10. Yes, obviously P4 with the 10 millisecond. So I'm going to pick the P4 now. Yes, so P4 start at the 8 millisecond, burst time is 10, 10 plus 8 is 18. At the 18 millisecond, P4 is also done with the execution. So I will mark this as a done. Now I am left out with which processes P3, P2 and P3. P2 with 24, P3 with 16. So obviously I'm going to pick the P3. Yes, so P3 start at the 18 millisecond, 18 plus 16 is 34. So at the 34 millisecond, P3 completes its execution. Yes, now I done with this also. So obviously you can see P2 is left out. So at the last we are going to take the P2. Yes, P2 with 24. So P2 start at the 34, 34 plus 24 is 58. By the 58th millisecond, all the processes are completed their execution. Yes, I guess this is clear how to put the Gantt chart. It is different from the first come first serve FCFS. So it's a simple if the arrival times are not given. If the arrival times are given, the calculation are going to be something different. That we'll see in the next example. But here you consider if in the problem statement arrival times are not given, it means implies that at a time all these processes are going to enter in a ready queue. I need to choose smallest. Once I choose the smallest, next process is left out processes in that which is the smallest. This should repeat until all processes are going to be executed. Yes, so I am clear with this. Next, we are going to see how to calculate the average waiting time and turnaround